Hey guys, so over here we'll be talking about the difference and similarity between basicity and nucleophilicity. They are similar but somewhat different. So let's analyze the terms. Basicity, it has the word here, basic, means to be basic. To be basic, meaning it needs to attract H plus ion here. Okay. Nucleophilicity has the word nucleophile inside, so this means need to form a covalent bond with carbon atom. Okay, so this part is mostly on the organic chemistry side. Now, when you want to form a bond, be it form a bond with hydrogen, H+, or form a bond with carbon, you need what? You need electrons. In fact, electron pair. So if you take a look at an ion, hydroxide, OH-, negative is on the oxygen. There are 3 lone pairs on this oxygen here. And we can use this lone pair to pick up the H and form a covalent bond with hydrogen, or I can use this lone pair to attack a carbon that is electron deficient. Right. So in this case, the hydroxide is both a nucleophile and a base. What about a hydride ion? H dot dot negative charge, a hydride. A hydride is able to pick up a H+ to form hydrogen gas. But it is unable to attack a carbon that is electron deficient. Why is that so? Now, hydrogen comes from the first period. So the valence orbital is the 1s orbital, which is really tiny and spherical. The carbon here comes from period 2. So in this case, it is a sp2 hybridized orbital, and with a larger size and higher energy, the overlap of the 1s orbital and the larger 2sp2 orbital is not good. To simplify things, basically, you have a very small spherical s orbital, and then you have a larger sp2 orbital that looks like this. All right. The overlap here is not efficient, which means that this bond, you can't really form it that easily. So a hydride is just a base, but it's not a nucleophile. So we call this a non-nucleophilic base. Right. Next example, what about ammonia Nh3? There's no charge here, but there's a lone pair on the nitrogen. Now this is able to attack a carbon that's electron deficient, or it can pick up an H+. Right? We know ammonia is basic, even though it's slightly basic, so it must be able to bond with H+ well. And you can tell from the formula itself, it's bonded to a hydrogen, 3 hydrogens in fact. So why is nitrogen able to act as a nucleophile? Because nitrogen and carbon are from the same period, period number 2. So that means the energy of the orbitals and the size are relatively the same. That means now we have an efficient overlap between the orbitals of nitrogen and carbon to form a bond easily. So in this case, it's both a base and a nucleophile. Right. Now, if you think about another ion here, let's say SH-, right? Using the same concept, do you think it is better as a base or as a nucleophile? Now the lone pair is on the sulfur, and sulfur comes from period number 3. period 3 and period 1, they would not overlap so much. But of course you can tell me there's already a SH bond here. But I can tell you this SH bond is on the weaker side because of the large difference in the size and the energy. Sulfur, period 3, has a similar energy to carbon, which is in period 2. So they can bond better. Sulfur of the SH negative ion would prefer to attack a carbon that is electron deficient rather than to act as a base to attract an H+. I hope you understand this, some subtle difference between nucleophilicity and basicity.